Hi, this is Bryce. As you can see from the slide, I'm going to be talking about something called hex. And this is just an alternative to the binary codes. I know you've had a chance to look at that in the project that you did earlier. So I wanted to tell you about this. It's actually kind of interesting. It's kind of fun, and you'll find it pretty useful as we go along. So hex, let me tell you about this. It's actually based on a word called hexadecimal. That's the actual official name of this. We call it hex for short, but that the derivation of the word is that the hex part of it stands for just the number 6, and the decimal, you probably guessed that, that stands for the number 10. So the whole thing together, hexadecimal, is based on 16. So that's this whole thing has to do with 16 things, and so you may recognize that. Obviously, it's a power of 2. So let me explain a little bit more about this. In hex, there are 16 symbols, and it's just the way that we count through the regular numbers, so 0 through 9. But then there's a bunch more, so it goes 0 through 9, and then you could just keep going on, and you get to A, B, C, D, E, and F. So those are that whole thing. Those are just the symbols that are used with hex. And it's useful for all types of data, just the same way that binary is useful for all types of data. It's really just the same thing. It's just another way to say it. So it would be good for text, and I'll show you an example here in a minute. And obviously for numeric as well. And then, of course, the digital media stuff. So that follows on. So let me continue on here. The way that you can convert text to hex is really the same way that you did with binary. So I'm just going to take my name and say, well, that's what my name looks like in binary. But rather than write all that stuff out, the zeros and the ones gets to be pretty hard to read. So this is where hex comes in. You can take that same thing and then just represent it as a series of two things together, so two symbols together. So the 42, that's an uppercase B. That's the first letter of my first name. And it just goes all the way through. And if you actually do the combinations of all the numbers, you'll see that every one of those binary numbers ends up being a hex number. So I'll explain how that works. There are actually some programs that will let you look at any kind of file on your system and then see what the hex symbols would be for it. It's kind of like looking at binary zeros and ones. It's just a little bit easier to read. So in this one, this program happens to have some stuff over on the right, and it says this is the source code package, and so then but it's just showing the text off to the left. I just picked something at random here. But I did want to show you that there are programs that let you deal with just the hex, and you can look at them, and then some programs let you actually alter the hex here. So you're really just altering the binary, but the hex version of the binary. I know that sounds confusing, but that's really all that it is. So then the next part, I'll go through this real quick, but you can convert numbers into hex very much the same way that you did on Project 2, where you converted the numbers into binary. So here's how it works. The regular counting system that we have, it goes up from 0 through 9, but then it does keep going on, and this is where you use the hex symbol. So A, B, C, D, E, and it'll stop at F. So obviously that's the 16th one. But those can then be numbers, and you can deal with them as numeric quantities. So let me show you something. Here's what the numbers look like. And I know this is going to sound funny because they don't look like numbers, but that's a number in hex. That's the number A. Well, it's a 10. That's the way we would think of it. A B in hex is an 11, and a C in hex is 12, and D 13, E 14, F 15. So that lets you count all the way up through 15. And then just so it'll bring you back to what you did earlier in the project, the binary versions of those, that's a 10, that's an 11, 12, 13, 14, 15. So I know I'm going through this fast, but this is just something that hopefully it'll jog your memory a little bit and you can see what's going on here. So anyway, that's what hex looks like. Let me show you how it actually works when you're working with numbers. So you can convert hex to decimal, and you can go the other way too. So let's take a look at this. Let's say I had something that was 1 F. And I just put the little hex down there as a subscript just to keep us informed about what we're doing. So anyway, that's a symbol, that's a number, 1 and an F. Well, the way you figure out what that is, it's actually pretty simple. You just break it apart into two things. So the 1 in binary is that. So a 1, that's the 1, obviously. The F is it's a 15. So that's all ones there. So that's how it breaks apart. And now to figure out the decimal version of that, you just take the whole thing and treat it like it's just a regular binary number. And so now you have to do place values and all the stuff you did in project 2, but you come up with 31 decimals. So those two things are equivalent. The 1F, if that's a hex, then you're talking about 31 as a decimal number. Let me do another one. So in this one, I'm going to deal with 7 and F. So again, you break it apart. So you say, well, the 7 is that. You might remember that. Oh, 1, 1, 1. So that's a 7. F, of course, is just what I just did. It's all ones. So that's the 15. And then same thing, you just group them together and treat them as if it's one long binary number. And so that then equals 127 decimals. So actually, that's a pretty common one. You'll see 7F a lot in hex numbering. It just happens to be one of the real common ones, and it's 127, which is that's a fairly common number also that you'll run into. Now, let me give you another one. So 3, 6 hex. Well, let's figure out what that is. The 3 is that, so that's a 3 in binary. The 6, I think you probably guessed what that one looks like. So that's the 4's place and the 2's place, so that's a 6. And then same thing, you just combine all of those bits and treat it as if it was just one large binary number, and it's figure out all the place values, and then you'll come up with 54 decimal. So I know this looks kind of weird because you have different values, like 3, 6 hex is not 36, it's just 3, 6. That's how it's said. And then 54 decimal, that's how we would pronounce that. So let me go on here. All right, now what about that one? Well, you probably see it already. That's F, and that's another F. So actually, those are both 15s. So we get 15, 15. So then if you take the whole thing together, and again, treat it like it's just one long binary number, well, then you'll get that. So that's actually the maximum that you can do in having that kind of symbols. So it's 0 through 256. So that's actually 8 bits a byte, and that's what hex looks like. So 2 hex symbols, in this case 2 Fs, and you end up with 255 as a decimal number. I think these things will show up in an example here in a minute. All right, let's do it the other way. So now you have a decimal number, and we're going to turn it into hex. So, all right, let's do the example we just did. 54 in decimal, in binary, sorry, 54 decimal is that number in binary, all the zeros and the ones. And so I've got them kind of separated there. You can see that there's in 2 groups. So if I take the first group, they're the group of 4, and I look at that, I say, well, that's a 3 in binary. So I'm just treating it as if those are just the place values all by themselves. They're that group of 4. And then if you do the same thing with the group of 4 that's on the right, then you'll get to a 6. And so then, we probably already guessed this, so 54 decimal is 36 hex. So it's just a matter of breaking the thing out into binary and then taking a look at just the 4 bits at a time, make a group out of them, and then just figure out the values, and that's how you do it. All right, digital media. That's another place where you can use hex, and you'll see it a lot there. In the example, I'm going to show you several examples. We're going to deal with colors. So digital media is perfect, hex is perfect. So same thing, binary, it will do the same thing. So you might see this if you ever deal with web page design or any kind of digital media, you'll start to see stuff like this. So this is a color. 7F36FF is a color. And so let me show you which one it is. And it's really easy to break it out. The first 2 that are there, the 7 and the F, that's the red. So that's the amount of red that would be in a pixel. And then the next one is the amount of green. So that's the 3 and the 6. Again, these are all hex numbers, so it's not 36, but it's 36. And then the last one is the blue, so FF. And so I'm sure you will remember this, but then all pixels on the screen are a combination of red, green, and blue. So you can kind of figure out what this one's going to do. The blue, FF, that's the maximum you can get. So there's a lot of blue in this color that I'm going to show you in a minute. There's a pretty good amount of red. That's what the 7F is. That's a pretty good amount. And then the 3,6 in the green is less. So you've got something that's going to be, let's see, a lot of blue, pretty good amount of red, and then a little to a lesser extent green. Well, you know what? That's what that is. So that purple color is that combination of hex characters, and so that turns it in. So it's very useful in digital media. All right, a few more examples that I think will make this a little clearer. So if you had these 6 symbols, and I just broke them into groups so you can kind of see the first 2 zeros, that's the red, the second 2 zeros, that's the green, and then the last one's the blue, red, green, blue. And so all those numbers, if they're all zeros, then you're gonna get black. So that's what black is. If you start to work on some combinations, then you're gonna see other colors. So here I made the amount of red, those are the FF, that's maximum amount of red, and then nothing else. It's all the zeros in the rest of the place. So that's just red. I'm sure you can guess what this one's going to be. There's like zeros for the red, FF for the green, and then zeros for the blue. So that's green. And these are all maximum amounts, so you see real bright, vivid colors here. And so, of course, then the next one is going to be the no red, no green, and then a lot of blue, and so that's the blue that you get. So you can work your way through these things, and I'll show you a few examples, and I think some of them will start to make sense. Let's say you had all Fs. So that would be the maximum amount of red, the maximum amount of green, and the maximum amount of blue. Well, guess what? That's white. So that you can go from black to white with all zeros and all Fs, and then anything in between. All right, a few more examples I think will make this a little bit clearer, I hope. So what happens if you have that? So that's no red, lots of green, lots of blue. So if you combine those colors, you're going to get a color that looks like that. So it's kind of a light blue. There's actually a name for that. I'll show you in a minute. And how about that one? Then you have a lot of red, no green, and a lot of blue. And so you'll end up with that magenta type color. And that's actually what it's called, is magenta. And then, of course, then the other combination is, let's see, lots of red, lots of green, and none of blue. So you end up with a yellow, and that's the combination. Well, you know, those colors that are up there on the screen, those are pretty significant colors. And so actually that's called cyan, magenta, and yellow. Those are the 3 colors that are used in inkjet printers, that if you're printing something and you want color out of the printer, you print in these colors. So in combinations of them, if you ever looked at an inkjet printer cartridge, if you've ever had to replace a cartridge in an inkjet printer, those are the colors. So it's those 3. Or a few more things just to show you how this might work. I just made that up, just totally random. So I've got a certain amount of red, a certain amount of green, and a certain amount of blue, and so it just ends up looking like that. This is just a random color. It does not mean anything. I did the same thing here. I just made up some random hex characters, and I just wanted to see what would happen. So that's another color. So this stuff pretty useful for digital media applications. Well, of course, the big question is going to come is how many colors can you do with this stuff? Well, we've probably talked about this earlier. You might have read about it earlier. So if they're all zeros, that's a starting place. And it goes to all Fs, that's an ending place. Well, then there's all those combinations in between of the zeros, not just zeros and ones, but all the way 0 through F. So all those 16, and anyway, you end up with 16.7 million combinations. And I think that number has come up before, so you may have seen that, or may have read about it, or we may have talked about it. So anyway, that's the amount of combinations that are available using this kind of lettering, numbering, and those kinds of symbols. There are some charts that you can use if you are a web designer, because this is the big, very important thing, is colors. And so I made a few of them, and actually I'm just going to put them on the slides and you can take a look at them. But there's one that just links to some background colors, text colors, and then something I call the ultimate color chart. So it's just, these are websites that will show you the combinations of the red, green, and the blue done with hex, and you can figure it out. So anyway, it's just an extension of binary, but it's just a different way to write binary, and it's a lot easier to look at than just the zeros and the ones. So that's what it's all about. Hex is something having to do with 16, and so it's 0 through F, that's the 16. Anyway, the next presentation will be about color, and so I'll show you how some of these things can be used. So when you get to the next one, you'll see a good application of that. All right, that's it. Thanks.